Hey class, Mr. Houston here, and today we're going to wrap up chapter 1 with lesson number 6, and that is classifying polygons. A polygon is a closed plane figure with 3 or more sides that must be line segments, and each side intersects exactly 2 other sides at each endpoint. Alright, so basically you got to have 3 sides, because if you have more than or less than 3 sides, you can't have a closed figure. Closed meaning that all endpoints meet together. There's no open spot. And then this one is key too. It intersects exactly 2 other sides at each endpoint. Okay, so we're going to talk about convex and concave polygons. Easiest way for me to remember it is down here with concave. I think of it as a cave. So like as that figure kind of caves in, this would be a concave polygon because of that part right there. A convex polygon would have to look like this. There's no caving in of the sides, so it's convex. So let's take a look at example number 1. First, we're going to determine if it is a polygon, and then if it is a polygon, we're going to talk about whether it is convex or concave. So a polygon gotta have all sides as being line segments, and we can only intersect 2 lines can only intersect at 1 point. So as I look at example 1a here, I can see that they are all line segments, but my problem is right here and right here. I got 3 lines coming in and not just 2. So because of that, this is not a polygon. And because it is not a polygon, we're not going to worry about whether it's convex or concave. Part B, though, if I look, I have all line segments for all my sides. If I look at each point on there, I see that exactly 2 lines intersected. So this is a polygon. And in this case, nothing is caving in, so this is a convex polygon. Example C, I got this rounded side right here, so that breaks the rules of a polygon, and so we aren't even going to mess with it. We're just going to flat out say this is not a polygon because of that rounded side. And in letter D, we do see that all these are line segments. We do see at every point there's only 2 lines, so this is a polygon. However, it does cave in. If you look right here, it caves in. I could draw a line or a point from here to here and connect those, and I'd go outside the polygon, which makes it a concave polygon. Alright, so hopefully you are able to see the difference between concave and convex and understand what a polygon is. So, some of the types of polygons, we always name polygons by the number of sides that they have. I'm not going to go through the list. All I want you to know is that once you get up to double digits and stuff like that, we start calling them an n-gon. So if it's like a 20-sided figure, we'd call it a 20-gon. I'm sure there's a technical name to it, but we aren't going to get that technical. I'm okay if you do that with a 20-gon. These ones here in the list, though, I would like you to know. Most of them you do know. I would pay close attention to these 2 right here. Those are the ones that usually get screwed up the most. Hex is 6. Think there's an X in 6 as well. And then 7 is heptagon. Okay, and then the last thing is what's known as a regular polygon. A regular polygon means that all sides are congruent and all angles are congruent. And you can tell that simply by these little tick marks. Again, remember, if they all have the same kind of tick mark, those sides are all the same. If they all have the same like rounded feature, then that also makes them the same. We also will talk a little bit about equilateral, which equilateral just simply means, and I believe it's over here in your notes, yep, equilateral means all the sides are congruent. Equa meaning equal, lateral meaning side, and then equiangular, just like it sounds, all angles are congruent. And then when both of those take place, we call that a regular polygon. Alright, so we want to classify these polygons by the number of sides. We're going to say if it's equilateral, equal angular, or regular. So let's take a look at the first one. So let's count the number of sides. We got 1, 2, 3, 4, 5, 6. 6 sides, so I know that is a hexagon. And as I look, all the angles are marked the same, all the sides are marked the same. So this is a regular hexagon. Take a look at letter B. Letter B, I got 1, 2, 3, 4 sides. 4 sides is a quadrilateral. And as I look at the angles, these angles are the same, but these aren't. So it's not equiangular. These sides are the same, but these aren't. So that's not equilateral. So that is just a quadrilateral. Okay? All right, and then the last one, we need to make sure that we look very closely here and count the sides. So what I'm going to do is I'm going to mark where I'm going to start. I'm going to start there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12-sided figures. The last one up there I want you to know, that's a dodecagon. Dodecagon. Do meaning 2, dec meaning 10. And now let's take a look at all the sides and all the angles. So all these sides are congruent, but the problem is that this is a concave figure. So remember, I can do that. It looks like it's caving in here. So it can't be regular because all the angles are not the same. So this is just simply an equilateral dodecagon. All right. So hopefully you're understanding a little bit about what regular means. Regular is one that is both equilateral and equiangular. Just know that equilateral is sides, equiangular is angles. All right, let's flip over to the back side, do a little algebra with it. So, table is shaped like a regular hexagon. We're going to highlight regular. The expression shown represents side lengths of the hexagonal table. Find the length of a side. So, the reason I highlighted regular is because, again, that means we have equal sides, and we also have equal angles. They're all the same. And the reason I'm saying that is because we care about the equal sides. By knowing it's regular, I know that this side is equal to this side. So I'm going to take my 3x plus 6. I'm going to set it equal to 4x minus 2. Got to get x's all on one side. I'm going to take away 3 x's on this side. Going to get 6 equal to x minus 2. Adding 2 on both sides, I'm going to get x equal to 8. Yeah, 8, not 2. So, like most problems, we don't care about what x equals, we want to know a side length. Does it matter which side we pick? No, because they are both equal. So I'm going to pick 3x plus 6. 3 times 8 plus 6. Remember, we just plug in 8 wherever we see x. This is 24. This is 6. So 24 and 6 is 30. And I need to put 30 inches because my problem had inches in it. So just make sure that you get a label there with it. Okay? So that's an introduction to classifying polygons. Remember, we classify them by the number of sides that they have. We also classify them by being convex or concave. Regular meaning equiangular, equilateral, and that's about it. All right, so if you have any questions, bring them with you to class, and we will see you then.